Hello friends, you are watching channel number Collage. This is my sincere effort to help you understand basic mathematics in a simple and easy manner.
In this video, we will talk about coordinate geometry, and the first topic that we will discuss is the distance formula. Let us understand the distance formula. Distance formula is used for finding the distance between the 2 points in a plane whose coordinates are known. Let us find distance between Px1y1 and Qx2y2. So we have these 2 points and we have to find the distance between these 2 points, that is distance PQ. We have distance QR as x1 minus x2. So this distance QR will be x1 minus x2. Distance RP will be y1 minus y2. By Pythagoras, we write PQ square equals RQ square plus RP square. For RQ, we will put x1 minus x2. And for RP, we will put y1 minus y2. We will take square roots on both sides and write distance PQ equals square root of x1 minus x2 whole square plus y1 minus y2 whole square, which is this quantity. And this is the distance formula which is used to find distance between 2 points in a plane. So we have distance PQ equals square root x1 minus x2 whole square plus y1 minus y2 whole square. In the first question, we have to find the distance between P minus 6, 7 and Q minus 1 minus 5. By distance formula, we have distance PQ equals under root x1 minus x2 whole square plus y1 minus y2 whole square. We will substitute the values, which will be minus 1 plus 6 whole square plus minus 5 minus 7 whole square, which will be under root 25 plus 144, that is square root 169. Hence, the distance PQ will be 13 units. In the second question, we have to find the value of y when the distance between the points 2y and minus 4, 3 is 10. Let us name the points. A is 2y and B is minus 4, 3. We have to find distance AB. So by distance formula, we write distance AB equals 10, which is given. Distance AB will be square root x1 minus x2 whole square plus y1 minus y2 whole square, which is by distance formula, and this distance is given to be 10 units. We will square both sides and get the right hand side 100. We will substitute the values. It will be minus 4 minus 2, 3 minus y, which will be 36 plus 9 plus expansion of 3 minus y whole square, which will be 9 minus 6y plus y squared equals 100, which will be y squared minus 6y plus 45 minus 100, which will be y squared minus 6y minus 55 equals 0. We will factorize the quadratic polynomial as y minus 11 into y plus 5 equals 0. That gives us y equals 11 or y equals minus 5 are the required values of y. In question number 3, we have to answer, do the points 3, 2, minus 2, minus 3 and 2, 3 form a triangle? And if so, we have to name the type of triangle which is formed. First of all, we will name these 3 points. A equals 3, 2, B equals pi raised to minus 3, C equals 2, 3. By using distance formula, we will find distance AB, distance BC and distance CA. So first, by using distance formula, we find AB, which works out to be 7.07. Next, we will find BC, which works out to be 7.21, and CA, which works out to be 1.41. We have AB equals 7.07, BC equals 7.21 and CA equals 1.41. Now, the sum of any two sides is greater than the third side. Therefore, we conclude that points A, B, C form a triangle. Question 4 is, find the distance of the point P, 2, 3 from the x-axis. We know that the y-coordinate of the point P, 2, 3, the y-coordinate represents its distance from the x-axis. So, distance of P, 2, 3 from the x-axis is 3. In question 5, we have to check if the points 1, minus 1, 5, 2 and 9, 5 are collinear. Let us first name the points. A is 1, minus 1, B is 5, 2, C is 9, 5. We will find by using distance formula first AB, which works out to be 5, then BC, which works out to be 5 again, and finally we will find out CA, which works out to be 10. Since AB plus BC equals 5 plus 5 equals 10, which is CA, we conclude that ABC are collinear points. In question 5, we have to show that the points 1, 7, 4, 2, minus 1, minus 1 and minus 4, 4 are the vertices of a square. First, we will name the points A, 1, 7, B, 4, 2, C, minus 1, minus 1 and D, minus 4, 4. By using distance formula, we will find AB, BC, CD and DA. So, side AB works out to be root 34. Side BC works out to be root 34 Side CD works out to be root 34 and side DA also works out to be root 34. Since all the four sides are equal, it proves that ABCD is a rhombus with each side root 34. We will rewrite the points for reference. Now we will find the diagonals by using distance formula. So diagonal AC will be root 68. Then diagonal BD will be root 68 again. Now since the sides are equal, AB equals BC equals CD equals DA, which is root 34H, and diagonals are also equal, AC equals BD equals root 68, we conclude that the points A, B, C, D form a square. In question number 6, we have to find the point on the y-axis. This point we have to find, which is equidistant from the points A 6, 5 and B minus 4, 3. This point and this point. This distance is same. A point on the y-axis has its x-coordinate 0. Therefore, we assume this point on the y-axis to be P0, y. So, this will be P0, y. We write PB equals PA because points A and B are equidistant from P. We will square them and write PB square equals PA square. Now we will apply distance formula by omitting the radical sign and write now we will substitute the values. This gives us 4 square 16, y minus 3 whole square is y square minus 6y plus 9, minus 6 square is 36, and y minus 5 whole square will be y square minus 10y plus 25. In the first step, this y square cancels with this y square. So it will be minus 6y. 16 plus 9 is 25. Then minus 10 and 36 plus 25 is 61. So it will be 4y, 10y minus 6y. And 61 minus 25 is 36. So this gives us y equals 9. So the required point on the y-axis will be P0, 9. So this is the required point. In question number 8, we have to determine if the points 1, 5, 2, 3, minus 2, minus 1 are collinear. We will first name these points. A is 1, 5, B is 2, 3, C is minus 2, minus 11. By distance formula, we will find AB, which is 2.24, BC, which is 14.56, and CA, which is 16.28. Now we will check if sum of the two segments equals the third segment. Here we observe that AB plus BC, which is 2.24 plus 14.56, it is 16.80, but this is not equal to 16.28, which is the length of CA. Hence, we conclude that given points are not collinear. In question 9, we have to check whether 5 minus 2, 6, 4 and 7 minus 2 are the vertices of an isosceles triangle. Let us name the points. A is 5 minus 2, B is 6, 4, C is 7 minus 2. By distance formula, AB is root 37, BC is root 37 again, and the remaining side is AC. Since AB equals BC equals root 37, we conclude that the given points form an isosceles triangle. In question 10, we have to find a relationship between x and y such that the point xy, which is this, is equidistant from the points 3, 6 and minus 3, 4. This is 3, 6, this is minus 3, 4. First, we will name the points. P is xy, A is 3, 6, B is minus 3, 4. We are given PA equals PB. That is, PA equals PB. P is equidistant from A and B. We will square it. So PA square equals PB square. We will use the distance formula without the radical sign. So it will be this. Then we will substitute various values of the coordinates of these points. After that, we will expand the brackets. We got this long expression. This x square cancels with this x square. This y square cancels with this y square. And we get minus 6x minus 12y. 9 plus 36 is 45. Here, this 6x minus 8y and 9 plus 16 is 25. Next, 6x plus 6x will be 12x, minus 8y plus 12y will be plus 4y, and 25u minus 45 will be minus 20. So we get 12x plus 4y minus 20 equals 0. We will divide throughout by 3 and get 3x plus y minus 5 equals 0. And this is the relationship between x and y that we have to find. We have discussed the distance formula from coordinate geometry. If you like this video, please click the like button. Do subscribe this channel to get more videos of this type. Thanks for watching. See you in the next video. Keep watching Number Collage. Thank you.